Okay, this is my second video, but it is the third attempt at the second video. In the previous two attempts, I was started on this question and I'm just going to skip it. You can read the values straight from the graph. I was trying to get the equations and it was just bugging me. So I'm going to skip to question 2. So if you need to have any help with question 1, I'll help you individually, but I just need to move on from that question. Okay, so question 2, for producing up to 30 items, the cost to a factory is $100 plus $30 for every item. So the factory, the cost is $100 no matter what, but every item is $30. So if it was one item, it would be 100 plus 30. If it was 2 items, it would be 100 plus 30 times 2, which is 60, so 160, and so on. The factory receives $35 for every item sold. Okay, so this is kind of like the break-even stuff that we did last lesson. Okay, so complete the table of values. So we've got number of items and total cost. And you'll notice that I've gone away from Word because I don't know what happened, but it's just weird now. So Adobe, please be kind to me. Okay, so the total cost. Now, if we've got 0 items, it's only going to cost us, or the factory, $100. Okay, so $100 goes in there. If there's 5 items, it's going to be $100 plus 30 times 5. So 30 times 5 is 150. And then plus that 100, so you should have 250. And you can see I'm going up by 5 each time. So you're going up by $150 each time. So the next one, 10 times 30 is 300, plus 100 gives you 400. Return from sales, this time we're just got $35 for every item sold. So if you've sold 0 items, you get $0. 5 items, 5 times 35. 10 items, 10 times 35. 15 items, 15 times 35. Okay. Show both the total cost and the return on the graph provided on the right. So let's go ahead and just do that on the calculator. So my calculator probably still has problems from last time. So let's just go new. No, I don't want to see that question ever again. Okay, so I'm going to put in here number of items. Actually, I'll do items. Okay, so number of items. You don't always have to use X and Y. Sometimes I find you can get easily confused if you're using X and Y. So we've got 0, 5, 10, 15. Then we've got the cost. So you can actually put in your equation here if you wanted to. So it's $100 plus 30 times items. Let's see if this actually works. So I can type in items. Okay, and it does it for you. Then the return from sales is, cannot accept, what? Doesn't like that. Do you like return? Sometimes the calculator is a bit weird. If it doesn't accept something, it's probably because it's something already programmed into the calculator. So return must be a function already in the calculator. So if we do RAT, that's our return. So it's $35 and it's times our number of items. So I can just type in items there. See how when I finish the word, so there's item, but when I put in items, it bolds it. So that just means it's already a variable. So items there, so it's calculated for us. Okay, show both the total cost and return on the graph provided. So it's wanting you to do 2 straight lines. So let's just go ahead. It's going to be fun. If I've learned anything from the previous 2 videos, it is to probably do things beforehand. No. Okay, so there's our scatter plot. I'm just going to draw a graph going straight through them. Wrong one. So we'll go regression, A plus BX. So there's our line. Oh, that's what it was doing to me before. and I don't like it. Why is it doing it in... I'm just going to pause and see if I can fix that. Okay, so I've taken out of scientific mode. So I just, oh, no, I didn't do that. I'll just quickly show you what I did. So if you ever need to change your settings, doc settings, document settings, and I just changed, what did I do? Exponential format. I had it on scientific and I just put it on normal, and that fixed it for me. So y equals 100 plus 30x. So that's the first equation. I don't know whether I can actually add another graph on here. No, I'm not going to try. So let's just go back here. So if you were to graph it, we've got 100 plus 30x. So you'd start here at 100 and you'd go to your end point. What was it? 450. So you'd go up to 450. Let's just go back to the calculator where the values actually are. Okay, so if I go here, so, oh, it was, sorry, 550. So the first point is 0, 100. The second point, 15, 550. So 0, 500, 15, 550 is here. So then you draw a straight line going through them. And then the other points, so this time if we were doing the returns, you're starting at 0 and your end point would be, not your end point because we're only going up to 15, but if you wanted to do 30, you can. The calculator will do it for you. So what I'm just saying, I put 30 there because our graph ends at 30. So it's just a little bit easier if you want to do the end points. Okay, so you go from 30 to 1050. I'm sure you can plot the graph. Okay, the factory breaks even when the total cost and the return are equal. How many items does the factory need to produce to break even? So if I go back to my calculator and I'm going to just add a page, add a calculator, because basically we've got two equations and you can solve using simultaneous equations. Now I know you guys are huge fans of solve system of equations, so I'm going to do it that way. We've got two, we'll leave them as x and y, just because it's a little bit easier. All right, so our cost equation was y equals, or c equals, 100 plus 30x, and our second returns equation is 35x. Whoops, I've got the y equals. Sorry, guys. Okay, you just highlight and press enter. Sorry. And then press enter. Okay, so that means when we've sold 20 items, our break-even point is 700. So to answer this question, how many items does it need to produce break-even? It's 20. So at the point 2700, that's when they will cross, the two lines will cross. How many items do you recommend the factory produce? Justify your answer. I would say 21 or at least 20. So then you're making some sort of profit. Okay, I'm going to pause there and I'll create another video in a sec. Oh, actually, before I do, because I just want to skip these two. Piecewise linear functions. So we've done piecewise, but we didn't do step graphs. Just so you know, step graphs won't be on your assessment task. Okay, but they're quite interesting, but just don't have the time to do it today. But I just realized these two, as I scrolled through, will probably be quick to go through, so I might do them as well. So Liam receives a fixed amount of pocket money each week. In addition, if Liam chooses to help his mother, she gives him an extra amount per hour for the time spent. Per hour? How many hours is the kid spending? Anyway, the graph shows the amount of money Liam might receive in pocket money each week. What is the intercept on the vertical axis? So vertical is going up. It's 5. What does it mean? So even if Liam does nothing, he still gets $5. What is the gradient of this line? So you just use your endpoints, or I always find the endpoints the easiest. So we've gone from 5 up to 20. So he's gone up $15 and he's gone across, and is that 7 or? It's a bit hard to tell. It does look like 7, doesn't it? It's definitely not 8. Okay, so then it's 10 divided by 7. I'm just going to just scroll and see what the actual answer is because there's no grid lines. Just give me a sec. Okay, so the answer has it as 7.5, so I'll stick with that. So if we've gone up 15 and across 7.5, so your gradient is 15 divided by 7.5 is 2. What does the gradient represent? So for every hour that Jules works for his mum, he gets an extra $2. Wow, this must be a very old question, or I just pay my son a lot of money. Okay, so the next one, Amy intends to ride a bicycle from Aden to Barton to raise money for the local hospital. The graph shows her expected distance from Barton in kilometres over time. What is the intercept on the vertical axis? So it's 90. What information does this tell us? So it just means that so this y-axis is her distance from Barton. So she's 90 kilometres from Barton. So she's riding from Aden to Barton. So you can say the distance between those two towns is 90 kilometres. So yeah, she's 90 kilometres from Barton. What is the gradient of the line? Okay, so it's 90, it's gone down 90 and across 6. So 90 divided by 6 is 15. Or it's negative 15 because it's going down. What information does the gradient tell us? It's basically her speed. So she's riding 15 kilometres an hour. Find the equation of the line showing all working out. Well, we don't really need to show much working out because we already know the y-intercept is 90 and the gradient is 15. So if we use the variables here, it's going to be d equals 90 minus 15t. All right, and I'll pause there. Thank you.